Hello friends, I'm Saurabh. Let's have a look at another interesting problem today, which is how to find the element that appears once in an array. The problem is to find the element that appears only once in a given set of integers while all other elements occur n times. Let's take some examples to understand the problem. Consider the following input array. Here, -4 appears only once, while 3 appears n times, where n is 4. So here expected output is -4. Let's take another example. If you observe this input array carefully, you would see all elements apart from 9 appear n times, where n is 3. 9 appears only once, so expected output is 9. Now let us discuss an algorithm to solve this problem. Here we will take one example to visualize the algorithm. Along with understanding algorithm steps, simultaneously we will execute these steps on the example and visualize it. The example input array is shown here, where all elements apart from 9 appear 3 times. 9 appears only once, and hence expected output is 9. Let's start with the algorithm. So first step is to create countSetBits array of size 32 for representing 32-bit integer, where countSetBits I represent count of ith set bit of all elements in the input array. Initially all elements of countSetBits array are 0. Then traverse all the elements of the input array, and for each element take the element and check for its set bits. If the ith bit is found to be set, then in the countSetBits array increment the count of the element at index I. We will pause here for a bit. Now we will visualize these steps first before moving ahead with the algorithm. You can see the input array on the left and countSetBits array at the bottom. Initially all the elements of the countSetBits are 0. Here bits representation as well as countSetBits are shown to be size of 4 for simplicity. Actual size of them are 32. Now we will execute steps 2 and 3. We have to traverse over the array, and for each element, if its ith bit is set, then in countSetBits array increment the count of element at index I. Now let's start iterating over the input array to populate countSetBits array. Okay? So 5 in bits representation is 1 0 1. So for each ith set bit of 5, we increment count of element at index I in the countSetBits array. Okay? So element at 0th and second index are incremented by 1. Let's move on to next element. Next element is again 5. So element at 0th and second index are again incremented by 1. Let's move on to next element in the input array. Next element is 4. Bits representation of 4 is 1 0 0. So we increment element at index 2 in countSetBits and it becomes 3. In a similar way, we will iterate over the remaining elements of input array and keep on populating countSetBits array. Now we will move ahead with the next step of the algorithm. After finishing the above operation for all the elements of the input array, the elements of countSetBits would represent count of all set bits in the elements of the input array. Perform the modulus n operation on each element of the countSetBits array. Modulus n operation will eliminate count of set bits of elements occurring n times. After the modulus n operation, if we get a remainder 1 at index j, then that means in the number that occurs only once, we have a set bit at index j. I hope this is clear. After the modulus n operation on each element, the countSetBits array represents bits representation of the required element. So set individual bits in a variable solution. Let's visualize the previous step of the algorithm. The current state of the countSetBits array is as shown here. After modulus 3 operation with each element and simultaneously setting individual bits in a variable solution, the bits representation of variable solution is 1 0 0 1, which is 9. We have found our solution. Time complexity of the algorithm is order of n and space complexity order of 1. Now let's see another algorithm to solve this problem. This approach can avoid having a countSetBits array and hence step 4 of previous algorithm. First we will have a look at the algorithm. These steps will be explained in detail with an example in subsequent slides. Do not worry if you do not get it right away. Initialize a variable solution to 0. Then set individual bits of the variable solution. To set ith bit position of the variable solution, calculate sum of all the ith set bit of all elements in the input array and mod it by n. Let's take an example to visualize the algorithm. Let's take the same example which was used to visualize the first algorithm. Bits representation of each element is shown here. We initialize a variable solution to 0 and hence all its bits are 0. We have to set individual bits of solution. Let's start with the iteration. How to set 0th bit position of the solution? First calculate sum of all 0th set bit of all elements in the input array. Here the sum is 4. Now mod it by 3. We get 1. Now let's calculate value of next bit position of the variable solution. Here the sum of all set bits of all elements is 0. Mod with 3 will also result in 0. So the value at this bit position of solution is 0. Let's calculate value of next bit position of the variable solution. Here the sum of all set bits of all elements is 6. Mod with 3 will result in 0. So the value at this bit position of solution is 0. Let's calculate value of next bit position. Here the sum of all set bits of all elements is 4. Mod with 3 will result in 1. So the value at this bit position of solution is 1. We will keep on doing this to set all remaining bits of the variable solution. Since for all subsequent bit positions, sum of all set bits of all elements is 0. So we can safely skip the visualization of that part. Finally, the bits representation of the variable solution is 1, 0, 0, 1, which is 9. We have found our solution. Time complexity of the algorithm is order of n and space complexity order of 1. Have you checked our iDeserve web portal at www.iDeserve.co.in? We are uploading new topics every day. Please check it out and leave us your feedback. Please let us know your valuable suggestion on current topic. If you liked our video, please subscribe to our iDeserve channel, like the video and share it with your friends. Thank you.